All right, so now that we've learned a little bit about exponential functions, we're going to go back to something that we learned earlier this year on sequences. So back in 4.5, we learned about sequences. And we said a sequence is a list of numbers that follows a pattern. Now, what we learned in 4.5 is that when the pattern was that you're adding the same number each time, that's what we called an arithmetic sequence. And we learned all about writing a formula for it and things like that. If the pattern is that you multiply by the same number each time, then it's what we call a geometric sequence, which is the title of our section today. So here's an example of a geometric sequence. The numbers 1, 2, 4, 8, 16, 32, ... I said that's geometric because what you're doing is you're multiplying by 2 each time. You start with a 1, and then it's times 2, times 2, times 2, times 2, times 2. That's the pattern. That's what makes it geometric. Here's another example. This one you're multiplying by -3 each time. So I said we're starting with a 4, then -12, then positive 36, then -108, then positive 324. So if you notice the numbers are alternating, negative, then positive, then negative, then positive. That's because you're multiplying by a negative number. Every time you multiply by a negative, it changes the sign back and forth. Now this one is a little tricky, but it is a geometric sequence. When you look at it, you might think to yourself, the pattern is I'm dividing by 2 each time. Starting with 160, divide by 2, divide by 2, divide by 2, divide by 2. The next number would be 5. Just remember, dividing and multiplying, just like adding and subtracting, are basically the same thing. Dividing and multiplying are also basically the same thing. Dividing can always be thought of as multiplying by a fraction. So what you could do when you look at this sequence, instead of thinking, oh, the pattern is I'm dividing by 2, you could think the pattern is I'm multiplying by 1/2. And that makes it geometric. So if you remember from 4.5, we had something called the common difference, or D, and that was the number you were adding or subtracting each time. Well, this time we have common ratio, or R. So the common ratio is the number that you multiply by each time. We're going to use R for it in our formulas. And here's our formula. It looks more complicated than the one from 4.5, but it's actually easier to use. If you remember from 4.5, we had to plug some numbers in and then we had to like solve for one missing piece. This one, you just put the numbers in and you're done. But you can always write a formula for a geometric sequence using an equals a1 times r to the n minus 1. Now remember, an means any term. So like, for example, A10 is the 10th term. A100 is the 100th term. A3 is the 3rd term. Or right here, A1 is the 1st term. So when you're finding a formula for AN, what that means is you're finding a formula that you can use to find any term of the sequence by plugging in a number for n. So AN is any term, and A1 is the 1st term, and R is the common ratio. So let's do an example. Here is a sequence. It is geometric because if you notice the pattern is you're multiplying by 2 each time. I start with a 5. You can start a sequence with any number you want. It's not what you start with, it's what you're doing to it. So I start with a 5, and then it's times 2, times 2, times 2, times 2, times 2. So I notice right off the bat, just by looking, 2 things. That was not working. Oops. Okay, there we go, that's better. Okay, I noticed 2 things. I noticed that it's geometric and that R equals 2. I also know that A1 is 5, just by looking at it, that's the 1st term. And that's all you need. So remember, I said what we have to write a formula for AN, we're going to use AN equals A1 times R to the n minus 1. So AN equals, now A1 is 5, and R is 2. And that's it. Remember, I said this is actually easier than arithmetic to find the formula. You just put the numbers in and you're done. Now, the second thing I asked you guys to do was to use it. I said, now I want you to find the 20th term. Now, the 20th term is A20. What that means is you're going to plug in 20 for n right here. So you get 5 times 2 to the 20 minus 1, or basically 5 times 2 to the 19th power. Now this is definitely a calculator question. I don't want you to try and do this by hand or anything. You know, what it means is 5 times 2 times 2 times 2 times 2, 19 times. And I don't want you to type that into your calculator, 5 times 2 times 2. Use the exponent button. Just type 5 times 2 to the 19th power. And I will check and come back. All right, what I got for that was a very big number. I got 2,621,440. So remember, this is like that example I gave you guys in the very first section of this module where I was talking about, you know, that job where you earn a penny on the first day, but it doubles each day. Well, we're starting with a 5, and it goes 10, 20, 40, 80. The numbers are getting bigger, but then all of a sudden, on the 20th term, you're in the millions already. You're at 2,621,440. So the idea is, if you're asked to write a formula for a geometric sequence, you always use this right here. AN equals A1 times R to the n minus 1. You plug in R, the number for R and the number for A1, and you got your formula. That's it. Real simple, what I did in purple. If you're asked to use it to find the 20th term or the 25th term or the 100th term or the 10th term, just take the formula you just created and plug in that number for n, use a calculator to get your answer. And that's it.